So the region R is in the first quadrant, bounded by y equals square root of x and y equals x over 3. Now, those are ones we could easily do this without a calculator, but we're given the option to use the calculator, so we may as well use it to save some time. So we can put those functions in for y1 and y2, so square root of x and x over 3. And let's take a look at the graph. I've already kind of adjusted my window here to get a little better picture. But we've got our square root function and our line. And we want to find the area in between those. So we're finding this area of this region. Now with area, remember there's no pi involved. It's just going to be the top function minus the bottom function if it's a dx cut, or the right function minus the left function if it's a dy cut. So the question is, which cut works? Dx, dy, or both? Both could actually work here, right? We could use a dx cut because the square root function is above the line the whole time. Right? Drew vertical lines, it would always go through square root function on the top, line on the bottom. But we can also do a dy cut. If we were to draw horizontal lines, always goes through the line first on the right, and then the square root function on the left. Since this is already set up like y equals, written in terms of x, dx cut is the easier option. We don't have to solve the equations for any variables. So I would go with dx cut. But it's good to know we could do either one, because actually we're going to need to use dy cut later on. For part A, though, we're just going to take the definite integral from a to b, which we'll figure out in a second, of the top function minus the bottom function. So our top function is the square root function. Bottom function is our line. We're going to have square root of x minus x over 3 dx. And we need to figure out what a and b are, our upper and lower limits. So, kind of obvious here, this should be 0. We can kind of check it with the equations here. If we put 0 in for x, 0 for y, 0 for x, we get 0 for y. So that's right. And this one, we can probably tell from the graph, but let's just check to make sure. We can do second trace. And we're going to calculate the intersection, which is option number 5. And I kind of already did it, so it's right there, but normally it's not going to come right on that intersection, so I'm going to hit enter on this graph, enter on our line, and enter one more time. And our intersection is at 9, 3. Right, so this point right here is at 9, 3. So we're going from an x value of 0 up to an x value of 9. And this one actually wants us to find the area, so we're going to go ahead and put that in our calculator. Sometimes it might just say set up the integral, and that might be on a free response with no calculator. But here it's asking us to find the whole thing. So I'm going to clear out of the graph. We're going to do math 9. We're going from 0 to 9, and we've got square root of x minus x divided by 3. And we're doing this in terms of x. So we end up getting 4.5000251. Some reason the calculator does this from time to time where it has this decimal at the end, but really, if we did this by hand, we should get 4.5. And anyway, we're rounding to 3 decimal places on the test, so we can just leave that as our answer, is 4.5.